Alright, let's get back to it. I know I had promised to do this video last week on the clamp knurling tool body, but because I had all week off, I thought, well, I'll get the body done, might even be able to finish the whole project. But unfortunately, some unscrupulous individual infected my website with malware, and since I'm a better machinist than I am a web designer, it took me all week to figure out what was going on and get it cleaned up. So that was pretty much a waste of my time. But the website's back in order, seems to be working fine. Pretty much all of it's been rebuilt, so if you guys visit it and find something screwy, just let me know and I'll dig into it and see if I can't straighten it out. But it seems to be working well. Everything's updated. A few things are different on it now. Mostly how you get to links. If you, it was a little awkward before. I don't know if you remember when the page came up with the three banners that you can click on to go to like the various projects, the beginners, intermediate, and advanced projects. You had to click on the line below where it says click here or whatever. Now you can click pretty much anywhere on the banner and it'll take you there, so that's kind of nice. But anyway, enough of that. Let's get back to business here. Today we're going to make the body for this clamp knurling tool. Let's get to it. So here's the print for the body. I saved you some grief. I cut out the stock ahead of time so you didn't have to watch me bandsaw this thing to size. So it's just a piece of 3/4 inch aluminum plate, 60/61. The overall dimensions of the part are 6 3/4 by 2 3/4. I sawed the part out an 1/8 inch oversize in both dimensions. That'll leave plenty of stock on the edges to clean up. Okay. The thickness on this thing is, I'm gonna talk about tolerances a little bit, more than I have in the past. If you look on the drawing here, the dimension on the thickness is 3/4 of an inch, 0.75. It's a two-place decimal. That means I have plus or minus 15 thousandths, according to the title block down here. Two-place decimal, plus or minus 15. So anywhere from 735 to 765 is good. Okay, what that allows me to do is just to use an ordinary piece of 3/4 inch stock. Okay, I don't have to do anything to that surface if I don't want to. But since this is going to be a tool, I think what I'll do is I'll take a cleanup cut on these surfaces just to make it look pretty. When this thing's done, I'll probably anodize it to make it look nice. So that is, it has a nice fly cut finish on it. It'll look a lot nicer than just a milled surface, mill surface from the as it came. So let's throw this thing in the mill and square it up, and then we'll talk about what to do next. Okay, so let's square this block up. Whenever you square up a part, you should always machine the largest surface first. Okay, that gives you a good reference surface to square all the other edges up too. So start out, let's do this first face here, one of these two faces. Okay, so I'll get some parallels in the vise, set the part in, and I like to use a piece of wire between the movable jaw and the sawed edge of the work. I know I've had a lot of questions on this. Why do you do that? Well, here's a good example of why I do that. Okay, this backside. This backside is already milled in this case, or it might have been a mill finish from the factory, just the way the aluminum was made. So it's a pretty straight surface. Okay, so I'm going to put that one against the jaw, but this front side is sawed. Okay, it's just a rough bandsawed edge, and it's not straight. So what I do when I put this wire in here, this wire fills in the gaps. Okay, it crushes when you tighten the jaw down, and adjusts to the shape of the edge. Okay, you can see here this whole right side is loose, left side's tight. But if I tighten the jaw down on the vise, the wire crushes. Now it's both edges are tight. It's tight all the way along this jaw, so there's no way this part's going to come out or cock in the vise. Okay, it's nice and rigidly held. That's why I do that. Alright, so I'm going to take a fly cut on the top surface here, just get it nice and clean. Let me grab some power. fly cutter, got safety glasses on, get your sleeves rolled up. Still working on that entanglement video. One of these days I'll crank that out, show you why I roll my sleeves up. Alright. You guys know how to figure RPM, I'm not going to go into that anymore. Now this stock is about anywhere between 5 and 15 thousandths oversized. So I don't have a lot of room to work with. If I want to end up with a nominal dimension of 3/4, of course it is a 2-place decimal, so I can go under. But I'm not going to take any more off than I absolutely have to. So let's just take a cut here and see where we're at. I like using fly cutters because they kind of keep you in tune with your machine. You can tell if the head is out of tram or not just by looking at the crosshatch pattern that the fly cutter produces. It's a nice crosshatch pattern here that tells me my head is pretty close to being perfectly trammed. Alright, that's one edge. Okay, now I'm going to use this edge as my reference surface, this face, and we'll flip it up, put the surface I just machined against the solid jaw, and we'll do the next largest surface here. I'm ignoring the bottom, we'll do that last. Right now I'm more concerned about getting the edges square with this first face we machined. So again, I like to use the wire. Just ensures a nice even pressure on the movable jaw. I've had parts move in the vise, I've had parts thrown out of the vise, so that's why I came up with this idea. This works real well. Alright, now I don't have to worry too much about stock. I got an 1/8 inch of stock on the width here, so I'm going to take a pretty healthy cut. Yeah, you can hear it's not very straight. That's why I use the wire. I'll just take a couple thousandths off going back just to clean it up nice. Then we'll flip it over and do the other side. Don't want to get too carried away in this first edge. You just take off enough to clean it up. If you go too far, you might not have enough stock on the other side to clean up, and you're going to be bandsawing another piece. Keep the burrs cleaned off. Alright, so we'll put the first surface against the solid jaw again, and then the surface we just machined down. Okay, now I'm going to tap it down. I'm using a nylon hammer. I guess I could use my ball peen. Either way, just tap it down tight. Now we'll take just a little cleanup cut, 5 thousandths or so, and we'll take a measurement. Alright, let's see where we're at here. We're shooting for 2 3/4 of an inch. So let's see where we're at. We're at 2.819. 75 minus, we have 69 thousandths to go. Always hold the work when you're tapping it down, because then you can feel when it's down tight. Okay? Otherwise you might be up on one end and tight on the other, and you wouldn't know it, and you end up with two edges on a part that aren't parallel to each other. So always hold on to it. Now we have to take off, what did I say, 69 thousandths. I'm going to zero out the dial on my table. Actually, I'm going to offset it 69 thousandths. So when I finish up, we'll be on 0. Okay, this is aluminum, nice heavy mill. I'm going to take all but 10 thousandths of it off in one pass. If you have a lighter milling machine, you might not be able to do that. You just have to know your machine. Just adjust the speed, so well, doesn't seem to be complaining, so just take it full speed. Kind of listen to your machine when you're machining. You can tell whether it's working too hard or not just by the sound of it. Alright, then 10 thousandths more going back. This will finish it off to width. Okay, so now we have one edge and one face and two edges machined. Now I'm going to pop it in the vise with the back side, or the side opposite of the first one we machined, facing up, and we'll take it down to our 3/4 of an inch thickness. Now we have nice machined edges to work off of. We don't need the wire anymore. So just put it in the vise and tap all 4 corners down. Again, rest your finger on the part so you can tell when it's down. When it's up in the air and you hit it, the part vibrates. You can feel that. Okay, if you hold on to it as you're tapping, you can tell when it seats down on the parallel. See, both these parallels are tight now. Okay. So let's go ahead and take a cut on top. Again, we're not working very much stock here, so you have to be a little bit careful. Don't take any more off than you need to. Take one pass and check and see where we are. We're at 747 right now. So already a little under that 3/4 inch nominal dimension, but looks like it's pretty much cleaned up. I'll take another 1,000th off. We got a little bit left in the corner here. That'll make it pretty. Again, back to that tolerance thing, even though we're under 3/4 of an inch, the part's still fine because we have a plus or minus 15 thousandths tolerance on that 0.75 dimension. When I designed this part, I took that into account to make sure the thickness, it's not critical, so I toleranced it as such. No sense putting a 3-place decimal on something that doesn't need it. It just takes extra time. Okay, so now we have four edges, four sides of it done. You know, for the last two edges, okay, I can use my fly cutter and I can set it up like this, but you know, that doesn't look very stable to me. I don't think I want to do that. So I think I'm going to leave it down like this. I'm going to switch over to an end mill, and I'm going to side mill the ends of the part. Okay. I could use a fly cutter, but it just doesn't look very stable. So I like this way better. Make sure the parallels are inside the edge so we don't take a cut on them. End mills don't like parallels. The mill doesn't care, but the end mill sure don't like it. So let me grab a 1/2 inch end mill here. Since I already have a 1/2 inch collet in the spindle. Run the speed up a bit. Since we're using a smaller cutter now, we can use a lot higher speed. Take off just enough to clean this edge up. Okay, this is the length of this part is also a 2-place decimal, so I'm going to cut corners here a little bit. I'm going to zero out my DRO, or the table if you weren't using one, just zero it out. Then we can just run over to the other end here and use the digital readout to size the part. Okay, the overall length of the part is 6.75 inches. So I need to move over 6.75 plus the diameter of the end mill, or 7 1/4. That'll be my finished dimension. Okay, 7.260 right here. That'll give me 10 thousandths cleanup. There's 7.250. Now, if I was just making this part myself, I wouldn't even check it. Okay, I know it's close enough. It only has to be to plus or minus 15 thousandths of an inch, but just for you guys, I'll measure it, show you where we ended up. Here we are at 6.756. Okay, close enough. So I'm going to stop there, move on to the next operation. Again, don't waste time chasing dimensions when you don't need to. Pay attention to these tolerances. It'll save you a lot of time and a lot of work. Stop when it's good enough. Alright, so now we have our stock squared up. Let's see what's next. Okay, I think we have a lot of things to do here. We can put these 8 counterbore holes in the surface, in the face. We can mill this long slot, and we can bore this hole, this 2 1/16 inch hole. Now, what do we want to do first? Let's see. Well, the hole's going to have to be bored with a boring head, so it's no fun really boring an interrupted cut with a boring head. So I'm not going to do that slot first. We'll just bore this hole through first. Okay, that'll be operation number 1. Then next, I'll probably mill this long slot in. Okay, then after that, we'll put the 8 counterbored holes in it. So let's get the boring head out. Okay, I've taken the liberty to set a few things up here just to save some time. These videos get incredibly long if I do the entire project in real time, so I cut corners a little bit, save you guys a little bit boredom. I don't think you missed anything. So let's take a look at the print here and see what we're going to do. Okay, we're going to bore this. Where am I? There we go. We're going to bore this 2.06 diameter hole in here. Again, 2-place decimal, plus or minus 15 thousandths. So it's about 2 1/16. And the hole, looking at the dimensions here, is 3 3/8 from the end on a 6 3/4 part. That's centered. And it's 1 3/8 up from the edge on a 2 3/4 inch part. That's centered. In fact, if I look at the entire part, all of the features on this part are symmetric. So I'm going to take that into account, and I'm going to set up my base point on this part on the center of the part. So I'm going to center up in the X, I'm going to center up in the Y, I'm going to locate all my features off of that center point. It's a lot easier than working from an edge, because then you have to keep track of the edge when you take the part in and out of the vise. This way I can put the part in the vise any way I want and it'll still be centered. Okay, so we need to pick up the center of this part then. I'm putting my work stop in, setting that up, so if I want to take the part out of the vise I can do so. So we'll just put it in, tap it down. It's always a good habit to get into, to tap your part down every time you put it in the vise. Sometimes it doesn't matter. In this case it's not critical. We're just boring through holes and counterbores and stuff like that. It doesn't matter, but we get on the other side of the part and mill the slot. Okay, that slot has a very tightly toleranced depth, so if the part's not tapped down, it's not a good thing. So let's go ahead and center this part up. Pick up the back edge, zero out my DRO or your dials. If you're using dials, you might not want to do this center thing because you have to compensate for backlash. You might just want to pick up one edge and move in half the part. But since I have the DRO, I can do this. Makes life a lot easier. Okay, that's centered on the Y-axis. Whoops, press the wrong button. Let's do it again. Zero it out on the back edge. Picked up the front edge, now I can hit the midpoint function and find the exact center of the part. Okay, so we're good there. Now let's do the same thing on X. I realize you can't see what I'm doing, but if you have a digital readout, you'll know what I'm talking about. Again, if you don't, you're just using dials, you're better off picking up the front edge and the left edge here, setting your dials at zero and working over from there. Alright, so we're centered up now on my digital readout. Read 0, 0. I'm right in the center of the part. Right about there. Okay. So now I'm going to bore this 2 1/16 inch hole through the center. So I'm going to lock my table down. I'm on location. Lock down both the X and Y axis so nothing moves, because we're going to be taking some heavier cuts. Okay, now I got to get this. I got to get a starter hole through the center of the part. So I'm going to use a big drill to do that. Or you can use an end mill or whatever you happen to have on hand, but you got to get a hole through for the boring bar. So I have a 3/4 inch drill here I'm going to use. Unfortunately, it's in a adapter that's quite long, so it means cranking the table way down, but we'll get there. Guess you guys can still see it barely. I'm going to have to adjust the camera. There we go. Okay, I'm going to put some oil on this. Okay, actually, I'm not going to use oil. I'm going to use some water-based cutting fluid. Doesn't make as big of a mess. It doesn't smoke. I like to use for tapping and things, small holes on aluminum, I like to use WD-40, but for big stuff like this, it makes a lot of smoke. So we'll just use this stuff to keep the drill cool and lubricated. The drill aluminum is kind of stringy, so it's good to interrupt the cut. Keep breaking the chip so it doesn't end up such a huge wad of chips on the drill. Alright, I don't know if you can hear me over that. That's been one of the issues on my videos. I've had a lot of, not complaints, but concerns that it's hard to hear what I'm saying over the machine noise. So I took some of the donations from my site and I ordered a digital audio recorder and a wireless mic. So when all that stuff comes in, I'll be able to put my voice on a separate track in the video, so I can control the volume above, overall above all the background noise in the shot. So during noisy operations, I can crank up the volume on my voice. You can hear what's going on. So that's something to look forward to in the future. Thanks a lot to all you guys who have contributed. That's how I spend the money. So it's stuff like that. So let's go over to the. Get this thing out of here. Switch over to the boring head. I'll show you how. I don't think I've done a boring head on any of the other projects, so I'll show you how to set that up. Alright, here's the boring head. Nothing fancy. Just an old Flynn boring head. Okay, I'm going to use this boring bit like this. I like to use high-speed steel. You can get carbide bits, but I don't do all that much steel. Most of what I do is aluminum, so high speed's fine. It's a lot easier to sharpen than the carbide. Every time I use a boring bar, I always take a cut on the end of it just to clean it up, make it nice and sharp. Then I'll just stone a very small, really small, just enough radius on the point to clean it up. If you get too big of a radius on the point of a boring tool, that's a big contributor to chatter. So mount this thing in the head. You have to kind of eyeball the tool bit to get the top of the tool bit parallel to the axis of the slide on the boring head. Okay. Then we'll just, like I said, just the smallest radius just to make it cut smooth. And I'm going to crank the table up here. Going to be taking some fairly heavy cuts with this thing, so I want to reduce the amount of extension on the quill as much as possible. Let me adjust the camera here so you guys can see what's going on. There we go. Now I'm just backing off the boring head so the tool can get a first cut in position for a first cut. That's pretty good. We've got a long ways to go. I'll start out taking about 100 thousandths per side. And we're going to have to slow this thing down a bit. And let's see what happens. Cutting fluid at the ready. I'm just hand feeding through it. When we get down to the finished cuts, I'll use the power feed. So like with a drill, I like to break the chips so we don't end up with such a huge gallon of chips on the boring head. You'll always get some, but try and reduce it as much as possible. one cut. Let's see, just for grins, let's see where we're at. We got to go to 2 1/16, and we are at 1 inch. So we got 1 1/16 to take off. That's a lot for a boring head. So this may be a while. I may actually cut out and finish it up. I'm going to be taking about, like I said, about 100 thousandths per side. This is 50 thousandths per turn, so 4 turns for each cut. And keep in mind with a boring head, as you move the tool out, the tool is effectively getting larger, so at some point you have to start slowing down the RPM. Careful pulling chips off like that, because they are sharp. They get hooked on something, you're going to get cut. That's all I'm going to say about that. Find out the hard way just like I did. And adjust your behavior accordingly. Alright, well, I'm going to check out here and take this out almost to size, and then I'll flip the camera back on and show you how to finish it up. Okay, we're back. Ran into a little bit of a snag. I don't know if you can tell or not, but I'm not using the boring bar anymore because the boring head ran out of travel. The bar wasn't big enough to reach. So we're back to the fly cutter. All right, you have to be flexible when you're machining. You have to be able to adapt to situations. So what I did is I just put the fly cutter in the boring head because it has a lot of offset. So I just ground a tool to serve as a boring bar for the fly cutter. Now I can reach it out as far as I need. I can easily get to this 2 1/16 inch diameter. So that's why I like to use high-speed steel tools. They're quick to grind. I whip this one out in a few minutes. I'll show it to you up close after I get done boring here, but you won't find this in any tool grinding chart. Okay, it's just adapted using the same principles as a turning or a facing tool. Okay, so it'll work as a boring tool. So let's. I just took a cut here and I set my dial on 0, so I'm going to measure this bore now and see where we're at. There are a number of ways you can measure it. Let's talk about that a little bit. Let's move it out of the way here so we can get to it. I guess you can still see that. Yep. Okay, well, since we're only machining this board to 2 places, the most obvious way is just measure it with a ruler. Okay? You should be able to measure within a 64th of an inch pretty easy with a ruler. If you can't, you probably shouldn't own one. Okay, so at this point I'd like to stop for a minute. I had a bit of a video mishap. The battery ran out, and I went ahead and finished the hole, took it to size with the camera off. Happens, okay? So what I'm going to do is I'm going to start here where the camera died. Okay, I was just going to show you 3 ways of measuring the diameter of this hole. Okay, the hole is actually a couple thousandths undersized, so we're going to call it undersized, and I'm going to start right where I left off before, and I'm going to measure it 3 different ways, and then we'll take a finish cut on it and call it a day. So let's go ahead and do that. 3 ways to measure a bored hole like this, since it is only a 2-place dimension. Diameter is 2.06 inches. The most obvious way to measure it is just to use a ruler. Okay, we should be able to measure within 15 thousandths with a ruler. Okay, well, I already know what this is. Okay, it's about 2 inches 60 thousandths. What a surprise. The other way to measure it is with calipers. either dial or digital, whichever you happen to have. Okay, you have to be a little careful. Dial calipers are difficult to measure bores with. You have to be a little careful with them. Make sure they're, wiggle them around. Make sure they're at the widest part of the hole and square up. Kind of feel in all directions and make sure it's. Let's do it from this way. You can see what's going on better. Make sure the jaws are in good contact with the side of the bore. Okay, I get 2 inches and 53 thousandths with the calipers. Alright, and the third way is with the telescoping gauge. Okay, we don't really, this is kind of overkill in this case because it's a two-place dimension, so we don't really have to use a telescoping gauge, but I thought it'd be a good opportunity just to show you how to measure with one. So what we do with the telescoping gauge, this is a transfer type measurement tool. It transfers the diameter of the hole to a micrometer. So we copy the diameter with this telescoping gauge, and then we measure the gauge itself with a micrometer. The way you do that is you loosen the lock on the gauge, compress it, put it in the hole, then you tip it off center a little bit like this, and snug up the lock, and then you kind of wiggle and walk it back over center. Okay, and it finds the widest part of the diameter. Okay, now you can just take a micrometer and measure it and see what your measurement is. In this case, it's 2 inches 58 thousandths. Okay, before it was smaller. All right, but it's 2 inches 58 thousandths. That means we have 2 thousandths to go to hit the 2.06 dimension. So I went and taken this tool bit out and everything, so I'm not sure how it's going to work out. We'll find out. Let's crank it over 2 thousandths of an inch and hope for the best. Back on 0. Yeah, well, it sounds like it's hitting all the way around, so it must be taking a couple thousandths off. When I'm boring, I always like to feed back out, take what they call a spring cut, just to make sure there's no flexure left in the tool. It'll leave a nice finish, right to size. That's that. Okay. We should be right on 2 inches 60 thousandths now, just for fun of it, just for kicks. Let's check it with the telescoping gauge again. And it better be 2 inches 60 thousandths, or I'm going to quit for the night. Actually, I'm going to quit for the night anyway, because it's after 10 o'clock. That's my witching hour. I don't normally work in the shop after 10. Alright, look at that. It's 2 inches and 60 thousandths. Alright. So we're good. That's how you bore a hole. Like I said, it is after the witching hour, so I'm going to call it a day. And tomorrow, we'll go ahead and mill the slot. End mill the slot in here to accept the knurl holders. And after that, we'll do the 8 counterbored holes. And then what's left? We got to put the 2 holes in the end, the 2 holes in the side for the locking screws, and then make the 4 angled cuts on here. That's all that's left to do on it. We'll finish that up tomorrow. But before I go, I like to take this fly cutter out of here and show you the tool that I ground. Remember, I said you wouldn't be able to find this in any chart, any tool grinding chart. So let me just show you. Let's see here. Turn this around so I can see what I'm doing. Okay. All right. So this is what the cutter looks like. Okay. And this is the cutting edge. We're feeding down, right? So this is the cutting edge. Treat this just like a turning tool. Okay. Except we're turning on the inside of a bore rather than the outside of a a rod. Okay, so this is the cutting edge, so it has to have clearance underneath. Alright, it has to have a little bit of back rake in this direction, away from the camera. Alright, and it has to have, in this case, I had to take a little secondary cut on the heel here to clear the bore. Alright, because we're turning, or actually we're turning right inside of a bore, so I had to make sure that the heel of the tool here cleared, didn't drag on the bore, so I took a cut there. But other than that, it's pretty much a standard cutting tool, standard turning tool, except it's used on the inside instead of the outside. So I guess that's it. Tomorrow, like I said, we'll do these other features and finish this part up. Talk to you then.